All right, lesson 1.5, part B. Still talking about polynomial functions and complex zeros, and it starts out with symmetry. So the terms even and odd describe the symmetry that exists for the graph of the function. So an even function, it says a function f is even if and only if when the point xy is on the graph of f, then the point negative x positive y is also on the graph of f. Is also on the graph, excuse me. So what that means is that the x's, I can have a positive x and a negative x are going to share the same y value. So what this is saying is that it's symmetric to the y-axis. All right, also tells me here that if I have f of negative x, it's going to be equal to f of positive x. So it doesn't matter if my x is positive or negative, we're going to get the same y. And so we use that when we're looking to try to find algebraically if something is even or odd. And so what you'll do there is you're going to replace the positive x in the equation with negative x, and you're going to simplify it. And if they are the same, if it's equal, then it's going to be symmetric to the y-axis. So basically, when you get done, if you get the same equation that was given, then it's going to be even. All right, an odd function, it says a function f is odd if and only if when the point xy is on the graph of f, then the point negative x negative y is also on the graph. So x and y will both change signs there, which means that it's going to be symmetric to the origin. Which these are a little harder to see than if it's symmetric to the y-axis. Symmetric to the origin just means it would flip across the x and the y to make both of them change signs. And algebraically, it tells us then that f of negative x will equal negative f of x. So if I plug in negative x in the equation, I'm going to get all the same parts, but the signs are going to all be different. And so algebraically, we'll know if when we get to the end, if all signs change, then we know it will be odd. All right, so determine whether each graph is even, odd, or neither. So looking at this graph, remember, if it's even, that means it's going to be symmetric to the y-axis. Those are usually pretty easy to see. We can see that that's going to be on B here. You can look at the points here. The y values are the same. The x's are the same, but one's negative, one's positive. But the big thing is you can tell that that y-axis splits this graph in half. So it is a mirror reflection across the y-axis, therefore B is going to be even. Now we can see neither of the other two have that, so they're not even. Odd means that we could reflect our graph across the x and the y-axis. Means that our x's and y's are going to have the same digits, but they're going to be opposite signs. So one's going to have a positive x, and the other one would have the same negative x. And one will have a positive y, and the other one will have the same negative y. So if you look at this first one on A, we can see it looks like here we have the point negative 1, 2, and here we have the point 1, negative 2. So notice the digits are the same, but the signs changed on both of them. Therefore, this one is going to be odd. Another way to tell is if I take one of these points, and so let me erase this one. I'm going to take that first one that I drew, and if I reflect it across the x, and across the y, I should land on the graph. And it doesn't matter which order I do it in. I could have went across the y and then across the x, and I would still land on the graph, okay? If you look at C, C is obviously not even. And if I take a point here, let's just use this one. And so let's say this is negative 2.7, I'm sorry, negative 1.7 and 3.25. If I go find positive 1.7 and negative 3.25, that would be down here. That point is not on that graph. Even without looking at the ordered pair, if I don't look at its ordered pair and I just try my across the x and across the y, if I go across the x and across the y, then I'd be somewhere down in here and it still wouldn't work. Okay, so just watch out for those things. So since it's not even, it's not odd, this one would be considered neither. Okay, example 9 says algebraically determine whether each of the following functions is even, odd, or neither. So to determine algebraically, this is where we're going to plug in that negative x for the x and see, do we get the same equation? If so, it's even. Do we get all the signs are changed, therefore it's odd? Or do some of the signs change but not all of them, therefore it's neither? So I'm going to plug in my negative x for x. So I have negative x squared plus negative x minus 12. I'm going to simplify this as far as I can and then compare it back to the original. Is it the same? It is not, so it's not even. Did all the signs change? No, only one of them did, so it is not odd, therefore this one is neither. Alright, so let's check the next one. We're going to plug in negative x for x. So x to the fifth minus 4x to the third. Plug in my negative x. Remember, a negative raised to an odd exponent is going to be negative. And so I got my minus 4. Negative x to the third is going to make that negative x to the third. And then I got to multiply this. So that negative x to the fifth plus 4x cubed. Simplify it all the way. Compare it back. Is it the same? No, therefore it's not even. Did all the signs change? Yes, every positive is a negative, every negative is a positive, so therefore this one is odd. And then C, let's try that one. Plugging in negative x for x. Remember, a negative number raised to an even exponent is always positive. So this is 2, and this can give me x to the fourth. Minus 6, and that would give me x squared. Can't simplify any more than that, so compare it. Is it exactly the same? It is, therefore this one is even. Alright, example 10, determine the symmetry, if any, that the graph of the equation will exhibit. So again, I'm just going to see, is this graph even or is this graph odd? And if it's even, I know that it is y-axis symmetry, and if it's odd, then it's going to be symmetric to the origin. Alright, so I'm going to take and plug in negative x for x. So I get negative 9x. This is minus negative x raised to an odd number. It's going to be negative x to that odd number. And then so negative 9x plus x. Compare it to the original. Is it exactly the same? No. Did all the signs change? Yes, therefore it's an odd function. And we know an odd function is symmetric to the origin. Alright, using differences to determine degree. So the degree of a polynomial function can be found by examining the successive differences in the output values over equal interval input values. The degree of the polynomial function is equal to the least value n for which successive nth differences are constant. And so it says use the table below to determine the degree of the polynomial. So it's kind of like what we looked at before when we were talking about like the slope of the secant line, how we looked to see what was the difference in those average rates of change. But however many differences you have that it takes to get that constant difference is going to tell you what degree the polynomial is. So on this one here, they gave us a bunch of ordered pairs. So let's look at our first differences. So we're going to see how far it takes us to get to the next one on these. And that will be our first difference, okay? So how do we get from negative 30 to negative 14? We would add 16. Negative 14 to negative 12, we would add 2. Negative 12 to negative 12, add 0. Negative 12 to negative 2, we would add 10. Negative 2 to 30, we would add 32. And from 30 to 96, we're going to add 66. So this one is obviously not linear because linear would have first differences that are constant. Then let's do our second differences. So we're going to go through here and we're going to do the differences of the differences. And that's going to give us our second differences. That'll tell us if this is quadratic. So 16 to 2, we would subtract 14. 2 to 0, subtract 2. 0 to 10, we would add 10. 10 to 32, we would add 22. And 32 to 66, we would add 34. So this one is not quadratic. Its second differences are not constant. Then we're going to do it again. And so this time we're looking at our third differences because this is our third time to do it. This will tell us whether or not this is going to be cubic. Negative 14 to negative 2, we'd add 12. Negative 2 to positive 10, we add 12. 10 to 22, we add 12. 22 to 34, we add 12. Since our third differences worked, that means that this polynomial is cubic. So it said use a table below to determine the degree of the polynomial. So this is a cubic polynomial, or this is a third degree polynomial. Which is a cubic, same thing. Because the third differences are the same. All right, example 12 says write a polynomial function of minimum degree whose zeros include the following with a is greater than 0, just meaning our leading term is going to be positive. So we have x equals negative 3 with multiplicity at 2, which remember means it's going to be there twice. X equals negative 1 and x equals 4 with multiplicity of 1 for both of those. All right. So when I go to write my polynomial function here, so f of x equals, I know x equals negative 3 is going to give me a factor of x plus 3, and it's there twice, so that means it's going to be squared. Or since we're going to write this, we're going to have to work this out, I'm going to write it twice. And then we have x equals negative 1, which means it's going to be x plus 1, and x equals 4, which means it would be x minus 4. And so let's go ahead and let's multiply. So I'm just doing FOIL here. I'll do the second one in just a minute, and I'm going to simplify this. And then I'm going to do FOIL to the second one. And I'm going to combine like terms. And then I'm going to multiply both of them. Sorry, I'm going to come over and do a box. So x squared plus 6x plus 9. X squared minus 3x minus 4. A little crowded here. Sorry about that. Alright, and so we end up with, let's see, I'm going to change colors here just to help us be able to see it a little better. So we get f of x equals, let's see, I have x to the 4th. Negative 3x cubed plus 6x cubed is positive 3x cubed. Negative 4x squared minus 18x squared plus 9x squared is negative 2 plus 9, I got negative 13x squared. Negative 24x minus 27x is negative 51x. And then I have that minus 36 at the end. All right, so there's my polynomial function. B says complete the table to help determine the behavior of the function. So I'm just going to put this in my calculator. I'm going to go to my table. X is -4. You can see that my Y is 24. -3 gives me 0. -2 is 6. -1 is 0. 0 is -36. 1 gives me -96. 4 gives me 0. And 5 gives me 384. All right. Then C wants me to sketch this. So these are just going to be my ones. And so it's really kind of tough, but I can see at -3 is 0. And if -4 is 24, it's going to be going up to it. -1 is 0, but -2 is 6. So it's going to have to go up and then come back down. 0 is going to be -36, so it's going to be way down here somewhere. And 4 is 0, so it's going to come back up to it. Probably more centered than that though. And then we can see 5 is way up there at 384. So our graph should look something like this. So it says on what interval is f of x greater than 0? So where is it above the x-axis? Now just be careful, that was supposed to hit right there. Didn't look like it really did too much. And so I can see it's above the x-axis on the far left there. So from -infinity all the way to that 0, which is at -3. Now notice this didn't say or equal to, so at the -3 it's not equal to, so we're going to have to close it with a bracket, a parenthesis. And then we can see that it's going to start there again, right after that, all the way to the next 0. So then from -3 to -1. And then it goes negative, which is the next question where it's less than 0. So I'm going to go ahead and put that down there. So this would be from -1 to that next 0 at 4. And then after the 4, we can see it's going to keep going up. So it's going to be above. So it's going to be 4 to positive infinity. And then we answered E there. What intervals is f of x less than 0? That means where is it going to be below it? And that's just from that -1 to 4. Okay, real zeros and polynomial inequalities. So it says if a is a real root of a polynomial function p, then the graph y equals p of x has an x-intercept at the point a, 0. Consequently, real zeros of a polynomial can be endpoints for intervals satisfying polynomial inequalities. You can solve inequalities involving polynomials using both algebraic and graphic techniques. Let's explore some common connections between inequalities and the positive and negative sign of the expression. So to solve f of x is greater than 0, just like we just did, we're going to find the values of x that makes the y's are positive. And to solve where f of x is less than 0 is to find the values of x that make the y values negative. Alright, so using sign charts, it says let f of x equal x plus 3 times x minus 4 squared. Determine the real number values of x that cause f of x to be 0, positive, and negative. And so the first thing we're going to do here is we're going to find the zeros. All right, and so we're going to find x. So we're looking for where x plus 3 times x minus 4 squared equals 0. And so we're going to separate them. So that means x plus 3 equals 0. And we could write out the x minus 4 twice. But what we can do is we can say this is where x minus 4 equals 0, and that exponent tells us that answer's there twice, which means it's going to have that multiplicity of 2. So I'm going to come down here and just write multiplicity of 2. Then I'm going to solve both of these. And so we can see we have zeros at x equals negative 3, and we have a 0 at x equals 4 that has multiplicity of 2. So A asks for the zeros, so that's what we're going to put there. So at x equals negative 3 and at x equals 4. Then I want to know where is it going to be positive. So to do this, I'm going to build a sign chart. Okay, so I'm going to put a number line here. It's got my infinities, and it's going to have those zeros on it. So we said there was one at negative 3 and there's one at positive 4. I'm going to pick some numbers in here that are in these intervals. So from negative infinity to negative 3, I would pick maybe negative 4. From negative 3 to 4, I would pick 0. And from 4 to positive infinity, I'm going to pick 5. And I'm going to plug all three of those numbers into the original equation there to see if it gives us a positive or a negative answer. All right, so let's go find f of negative 4. So our equation is x plus 3 times x minus 4 squared, and we're going to plug in negative 4. So it's going to give me negative 1 times negative 8 squared. It's negative 1 times 64, which is negative 64. So I know that this part of my graph is going to give me negative numbers. It's going to be below my x-axis. Then I'm going to do the same thing with 0. So I'm going to go find f of 0. So I'm going to plug in 0. It's going to give me 3. It's negative 4 squared, which gives me 3 times 16, which is 48. So it's going to give me a positive answer. So everything between negative 3 and positive 4 is going to be above the y-axis. And then I'm going to go plug in 5, and I'm going to have to do that over here. So I'm going to plug in 5. Solve it. It's positive, so that means everything from 4 to infinity is going to give me a positive answer. Most of the time these will alternate, but notice between the right there surrounding the 4, they were the same, and that's because it had even multiplicity. Okay, if you look at x equals 4, that's where we said it had multiplicity of 2. 2 is even, so therefore it's going to be the same. It's not actually going to, well, we'll talk about that later, what it's going to do at that point. All right, so I want to know what intervals is it positive in. And so we can see that it's positive from negative 3 to 4 and 4 to infinity. You have to write them separate because at the 4 it's actually equal to 0, and 0 is neutral. It's not positive nor is it negative. Okay, and then C wants to know where is it negative. Well, we can see it was negative from negative infinity up to negative 3. All right, example 14 says solve the following polynomial inequality in the way indicated. So the first thing it wants us to do is factor, and remember, in order to factor, it has to be set equal to 0. So we're just going to move this 4x squared over and move the 16 over. And I'm also going to write them in descending order of the exponents here. So we have x cubed minus 4x squared minus 4x plus 16, and it's less than or equal to 0. Now when we go to factor this, when we find those zeros are what they call critical values, okay? Because that's where something critical is happening in on our graph, or in our equation. So when we factor, though, to find those critical values, we treat it like it's an equal sign. And so for our purposes right now, I'm going to just put an equal sign there. But I needed that first equation because when I go to check this using my sign chart, I need to remember, was it going to be positive or was it going to be negative? Is it less than 0? Is it greater than 0? So I need to know that. All right, so to factor this, I notice I have 4 terms, so I'm really hoping we can factor by grouping. So let's try it. So I'm going to take out an x squared out of this first group, which leaves me with x minus 4. Take out the negative 4. Oops, you know what? That's supposed to be 16, and I just wrote 6. I wrote 16 up when I was moving it, but I didn't put 16 here. Sorry about that. Okay, since they are the same, they are factorable. So we got x minus 4 times what we had left on the outside, the x squared minus 4. I can keep factoring. That last one is a difference of squares. So the square root of x squared is x, square root of 4 is 2, so we know it's going to be x plus 2, x minus 2 equals 0 to factor. Now to find those critical values, we just set each of those factors equal to 0 and solve. So we can add the 4, subtract the 2, and add the 2. And so we have 3 critical factors at 4, negative 2, and positive 2. All right, so to graph this analytically, using our sign chart, I'm going to draw my number line. It's going to have my infinities, and it needs those critical values in numerical order. So negative 2, positive 2, and 4. And then remember, we're going to pick numbers in each interval. So I'm going to pick like negative 3. Don't go dramatic. If you're looking from negative infinity to negative 2, yes, you could pick negative 100 if you wanted to, but you're going to plug it in and do some algebraic work with it. I advise you to stay close to that critical value. Negative 2 to 2 is 0. I would pick 0 if it's in that interval, if it's possible to pick. 2 to 4, so how about 3? And 4 to infinity, I'm going to pick 5. And so I'm going to go in here and I'm going to plug them in. You can either use the form where we got the 0 at, okay, or you can use the factored form, the polynomial form where we got the 0, or you can use the factored form there, one of those two, okay, to find out if it's positive or negative. Sometimes the factored form is easier just because you have the smaller numbers. So when I plug in the negative 3, we'll work it out, and I'm going to get a negative number. When I plug in 0, I'm actually going to get positive 16. When I plug in 3, I'm going to get a negative number. And when I plug in the 5, I'm going to get a positive number. And if you need to pause this video to plug them in and check it, do so, okay? Make sure. All right, and then for my solutions. Well, this is where I have to go back up in the problem. And what am I looking for? I'm looking for where it's going to be less than or equal to 0, which means I'm looking for where it is negative, and because it's equal to 0, that tells me I'm going to use a bracket at any numbers, okay? So I can see here that we are negative from negative infinity to negative 2. Whoops, almost put the wrong number there. With a bracket. And I'm negative from 2 to 4. And then graphically, we could graph this equation. All right. And so I know I have zeros at 4, 2, and negative 2. And when I look at my graph, I can see that it looks something like this. And so I'm looking for where it's less than 0, which I can see is down here. So from negative infinity to negative 2. And then it's below the x-axis right here, which is from 2 to 4, the same exact answer we just said. So we said it's negative infinity to negative 2 has equal to, so we put the bracket, and then positive 2 to 4. Same solution, different ways to work it.